Welcome everyone. And this lecture we are going to plot we are going to draw the projection for these 2 points. And out of these two, one is for in which we have to in first question we have to draw the left side view because the projection is 40 mm from RPP. Projection is on right projection plane. So this question is about the left side view, and this in this second question the projection is in LPP, left projection plane, which is at a distance of 25 mm. So it refers to the right side view. So let's start with some understanding of this question. A point says 60 mm below HP. For example, this is a quadrant system, and this point is C is 60 mm below HP and 70 mm in front of VP. It means below HP this one, in front of VP in this side. So the point C is in fourth quadrant. So front view will be here C dash, top view will be here C, and this have to rotate by 90° in clockwise direction. So C will come here. So C dash and C both will be below the XY line, reference line. So again XY points C will be like this, and the distance is below HP is 60 mm and in front of VP is 70 mm. So C dash is at a distance of 60 mm from the origin and C is 70 mm. So first we have to draw C dash, then top view C. This one is C dash and this one is 60 and this one is 70. Now in the question it has been asked, draw its projection 40 mm from RPP. Again it is given RPP, it means left view, and is on the right side of the projection. The distance between these two is 40 mm. So from here we have to take a distance of 40 mm, and then at 40 mm distance you have to draw x1 y1 and again follow the same step as we have done in the previous one. Now for this next question, we have point D, quadrant system, point D which is below HP and behind VP. So behind VP is left to the VP. So this is a point D which is in third quadrant, 35 below HP and 20 mm. This is 35, this distance vertical, and this horizontal distance is 20. So point D is in third quadrant, and its projection will be top view will appear here and front view will appear here. So this top view will in HP, that is why it will rotate by 90°, and after rotation it will go here and distance will be 20. So at 20 mm distance from the reference line in the upward direction we will have our top view, and downward at a distance of 35 mm just below this reference line at distance 35 mm we do have our front view. So again this is our XY line, this will be at a 20 mm distance we have our top view, at 35 mm distance we have front view, and point is 25 mm from LPP, and point is on left projection plane, so we have to consider right side view. So reference point, this reference line will be at a distance of 25 mm. Now you have to draw a reference line which will be x1 y1. Now you can again follow the same steps as we have done earlier. So now we are going to plot this thing in AutoCAD. So question is 60 mm below HP. So this is our projection 60. Okay, we're going to change the layer, construction layer. Construction. Now point is 60 mm below HP. It means our Front view is at a distance of 60 mm and in front of VP 70. So 60 to 70, 10 mm distance. Just take 10 mm in the downward direction. So just measure this linear distance from here to here to 70 mm and from this point. This distance is 60 mm. At 60 mm we have our at 60 mm we have a front view because see below HP. So front view will be here, which is represented by C dash, and top view is 70 mm in front of VP, so it will be represented by C. Now the point is 40 mm from RPP, so I'm going to take this line, set a distance of 40 mm in this direction. So this dimension is 40 mm. Now from this point of intersection, you have to draw a inclined line you have to draw this inclined line which will be in the direction of top view and should be at an angle of 45 degree with the XY. The top view is here, so I'm extending this line up to this point. Shift at the rate, tab, minus 45. So this line should be at an angle of 45 degree, correct? Now from this top view, you have to create a horizontal line which is going to intersect with this inclined line. Now from this point of intersection, we have to draw a vertical line which will be in the direction of front view. Front view is just above the top view. So I'm extending this line up to this point. Now from this C dash, going to draw a vertical line which will intersect with this vertical line. Going to draw a horizontal line which will intersect with this vertical line. So this point of intersection is our side view, which is represented by C double dash. C double dash. This point is on, this view is on RPP. So the view is left side view. Now we need to just move this thing a little bit high. Okay. Just need to use the donut to highlight the point. Donut inside 0, outside 1. First center is here, second center is here, which is the top view. Third one is our side view on RPP, which is here. So this is our projection of point, which is in fourth quadrant, and side view is on RPP at a distance of 40 mm. Now, next question was this one. Point D is 35 below HP and 20 mm behind BP. It's third quadrant. Projection will be just opposite to the point which is in first quadrant. So if our point is in first quadrant, then front view is above the XY and top view is below the XY. Now it is in third quadrant, so front view will be below the XY and top view will be above the XY. So again, 35 below HP, so front view is in the downward direction, which is, again you have to change the layer. Construction line drawn with the help of section 0.13 mm line thickness. So 35, our front view is in the downward direction, which is 35 mm below HP and 25 mm behind BP. It means top view will come in the horizontal plane. It have to rotate in the clockwise by 90 degrees, so it will come above the XY. So distance is 20 mm behind BP, so it should be 20. Now you can check the dimension. This is 20 and this is 35. And now next part is point, the side view is 25 mm from LPP. So side view is on left projection plane, so here we have a right side view. So left projection plane 25 mm. So I'm going to take reference line at a distance of 25 mm, create an offset distance 25 is this direction, just click it. So this line, reference line, is at a distance of 25 mm from the projection. Now you can name these things. Just do this thing. This one is our top view, 4.D, and to here, and this one is D dash front view. And now next step is to create an inclined line. So from this point of intersection, you have to create an inclined line in the direction of top view. See, top view is on the top side of the XY line, so I have to make a line this way. Select this thing. Now the distance between this line and this XY should be 45. So from this, it should be 90 plus 45, 135. So just press shift at the rate, tab 135. Now you can check the angle between this one and this is should be 45, so it is correct. From here to here it is 135, that is why this one is 45, because from here to here it is 180. So now just do one thing. From the top view, next step, from the top view create a horizontal line active this thing, and which will intersect with this one, this inclined line. Now from this point of intersection you have to create a vertical line which will be in the direction of front view. Front view is downward, so just create this line like this. Now from this point of a D dash, draw a vertical line. This is not long enough, so what I'm gonna do is just extend this line a little bit, provide the extension limit. I use this extend command, click on this, so it is extended up to this point. Now remove this thing. Now from the front view, D dash, draw a horizontal line which will intersect with this vertical line at this point. So this point of intersection is our side view, or our right side view, which is on LPP, left projection plane. Just name this thing D double dash. Now it is left. Okay, we need to highlight the points, so just use donut. Inside 0, enter. Outside 1, enter. This one is first center, which is our top view. This one is specify second center. This one is our front view, and this is our right side view, which is on left projection plane. So this is our solution. Okay, thank you. That's it for this video.